Welcome to VLearn. Today we have to start from the directory level structures. Now we will start with the single level directory structure. In this we have the list of entries, one for each file. In this we have the sequential file with the name of the file serving as the key, which provide help in organizing the files in a single level. Like these are the number of directories which we have, and inside these directories we have the number of files which are located in the circular manner, which are positioned in a circular manner with the directional arrows in respective of the directories. Provide no help in organizing the files. Force user to be careful not to use the same name for different files. Every user have to use the different number of file name with the different number of directories in respect of storage of that file in particular directory. Now into the next two level scheme for a directory. One directory for each user and a master directory for that particular user is there. Need to store that particular content inside that directory. In that master directory contains entry for each user which provides address and access control information to user. In the given diagram there is the number of users are there, user 1, user 2, user 3 and user 4. Every user having the number of files and extended level in which we have the two level directories. A single level is the master file directory level which reference to the another user file directory and having the number of files in respect of every directory, which is representing here with the circular form in directional arrows. Every user having their respective directory or subdirectory and sub files. So this is the two level directory structure in which here is the master file directory which represent the number of users, and this is the user file directory which represent the number of directory which are created by a single user. Like this is the directory in which there is the 4 directories created by user 1 which is referencing to this, and the same manner user 2 created only 2 directories like test and hello1 and having the number of files in respect of these directories. Same manner we have the number of users and we have the number of directories, we have the number of files in every level. So still provides no help in structuring collection of files but referencing the number of files and directories which are considering in respect of number of user and which represent the users and which represent the creation of users level at particular file system at particular directory level. Now the next is hierarchical or tree structure directory in which we have the master directory with the user directory. Underneath it each user directory may have subdirectories and files as entries, as we discussed in the previous slide, in which there is the number of levels in the master file directory and it is referencing to the sub user directory and that will reference to the user files. Same manner if we have the hierarchical structure and the number of directory structure in multiple levels, in that manner we have the multiple directory structure at multiple levels and every level is subdivided into n number of other level which represent the it contains number of files or number of directory inside it. So there is another example in which there is the master directory which have the number of 3 subdirectories and every subdirectory has the number of other subdirectories as well as the number of files in the same level, but it can represent the number of files at the further levels. So when we have the number of levels for representing the files and directories that can undercomes inside the subdirectories, and you can say the number of hierarchical manner of directory structure in which we have the multiple levels for representing the directory and number of files. So this is the tree structure in which we have the single master directory as the root level and the number of child at different levels where it represents as the leaf and at representing the number of subdirectory which referencing to the number of respective file structures at the last level. So the next topic is hierarchical or tree structure directory in a particular format where a number of users represented in a particular segments in which there is a user A, user B, user C. This is the another example for tree or directory structure for hierarchical, where the every user having the number of referencing directory and number of referencing files. In this, user B having the greatest number of directory at this level and referencing the every directory to the number of unit at the further next level, which represent the number of files at every case. In that scenario, the number of files having the same scenario, we have the number of files at every structure referencing to the next structure and to the next structure at the last level. This level is continued till we have the number of directories at particular level at particular end of directory. So the next is hierarchical or tree structure directory. Files can be located by following a path from the root or master directory down various branches. Suppose we have a tree structure in which A at root level, B, C, D at further directory level or subdirectory level, and they are having the another directory level. Then we can reference and give the path from A to B and B to C, C to D in that manner that represent the number of list and that represent the number of linked list or adjacency list, which reference which directory having the which kind of file and which directory referenced by which one master directory. In this, file can be located by following a path. This path name for the file we can have several files with the same file name as long as they have unique path name for every file, because every path is represents in the form of referencing directory which are having or in respect of the directory or master directory structure. So we'll continue to this process into the another example, that is the directory structure in which current directory always works as a working directory and reference to the files in the next level which represent the file directory level or referencing file of the user current directory which available for the user for working or storing the content. Next is the cyclic graph directory. As the name suggests, this scheme has a graph with no cycles allowed in it. This scheme added the concept of shared memory or shared common directory file which exists in file system in two or more places at once. Having two copies of a file does not reflect changes in one copy corresponding to changes made in the other copy. So this is the example in which we are representing and referencing the same file by two ways and updating the content by one way is not reflected to the another way. So the changes made by one copy is not reflected at the another level. Then we require the kind of reference which reflect the number of changes and can get the number of changes which are done by previous levels. A cyclic graph does not allow cycles in it. However, when cycles exist, the reference count may be non-zero even when the directory or file is not referenced anymore. In such situation, garbage collection is useful. So garbage collection does the task of remove the content or remove that content which is no longer required and which is not useful, and provide that space for further allocation and uses for processing and working on that space. This scheme requires the traversal of the whole file system and marking accessible entries only. In the second pass, then collect everything that is marked on a free space list, which is referencing here as similar to the previous diagram in which we are having a single file which is referenced from multiple ways and having the updated content. Disk space management, which is also a very important task inside this. There is the two ways of disk space management. There is a continuous and non-continuous. In a continuous, we have the number of locations in a continuous manner in like 1, 2nd, 3rd, 4th, 5th, but in non-continuous way we have the number of location in discrete way, and in a discrete form the first location can be 10 and the next location can be 50, but the node which is storing at the 10th location having the address of the next node location and also having the data. So this indexing or chaining will continue till the end of the list at the end of the list it is not referencing to the further node or list. So we know the list or the node which is having just an information, and at referencing part it is having the null part, it is the end of the list or end of the part of linked list. In disk space management, there is the continuous method and link chain method. The popular non-continuous storages allocation schemes are linked chain allocation, indexed allocation, in which one node refers to the another node. In linked chain allocation, all files are stored in fixed size blocks and adjacent blocks are linked together like a linked list. The disk block may be scattered anywhere on the disk. The directory contains a pointer to the first and last block of the file, which refer where to start this node and where to end this list. So we know by that how memory spaces and how references are there for visiting the number of nodes. In disk space management, indexed allocation, each file has its own index block. Each entry of the index point to the disk block containing actual file data. That index keeps an array of block pointer for each file, where every file knows where it is stored and where is the next location of data, and the last node having the null reference for further node reference. That's represent this is the end of the list. The advantage of this scheme is that it supports both sequential and random access, which help us to access the file in a both way and retrieving the content in same manner. The searching may take place in index block and themselves. Next is disk space management. In this, we manage the disk space by using the chaining or link method. In this, it is the directory which have the initial node address, that is the 100, and we point out this is the 100th location. At this address, it is having also the address of the next location, that is the 300. We have to move from 100 to 300th location. From this location, we have the next position or next location address, that is the 200. From this location we have to move the 200th location, and this is the 200th location, and it is having the end of file or a null pointer which is not having the next referencing to the another location. So we can understand this is the end of the list. Same manner, in indexed allocation, we have the directory structure in which it stores the file name and their index block, and every index block having the linked connection list where it is connected and from which node it is connected for exchanging or for referencing. And there is the two examples, that is the 15th which is having these number of nodes link, and 4th which is having these number of nodes links. So this is referencing, this is the indexed allocation method, and this is the link chain allocation method. Next is file related system services, which we work and which we do when we are working or operating the number of files. These are the number of process, these are the number of operations which we use for interpreting and for working the files, like creating a file, delete a file, rename a file, display a file, creation, remove, and another some processes like list the content of that directory, search for a file, and traverse the file system to know which content is stored and which is used for which purpose and where we can locate it. Now the programming services. In this we have the create or remove directory services, change directory services, and then we have the change directory entry also, in which we have the read and change directory operations facility also. In that way we have the options by providing input in a asynchronous input as well as output. Asynchronous input output operation run in the background and do not block user applications. This improves performance because input output operations and applications processing can run simultaneously. To manage asynchronous input-output, each asynchronous input-output request has a corresponding control block in the application's address space. This information is provided in any of three options or ways by which we can access, store and retrieve the content. The application can pull the status of the input-output operation. The another is the system can asynchronously notify the application when the input-output operation is done. Another one is the application can block until the input-output operation is complete. These are the number of ways which we can use or which we can follow for the processing of files. The next is content will on the next slide. The next topic is security and protection, that is the block 2 and unit 4. Topics to be covered inside this: security threats, security policies and how to implement these policies for preventing our files with compromising of security and compromising with the data throughout the network and where they are sending or traveling on the network. So protection in computer system, security models are used, access metrics are maintained and mandatory access control is there, which represent which node is controlling and which node is accessing and which node having the links to access the particular vertices and the particular nodes inside the control. And this is the also covered inside this, and which is having the referencing and controlling in accessing and in providing the accessing in particular files which are secure and provide the access in a secure manner as well. So the first topic is introduction about the security. Computer security is traditionally defined by three attributes of confidentiality, integrity and availability. Without these attributes we cannot assume about the security, we cannot explain the security, how it works and how it is required for us. Confidentiality is the prevention of unauthorized disclosure of information and unauthorized accessibility of information without any permission set, without any permission privileges. If anybody accessing our content means it is compromising with the confidentiality of data and it is unauthorized person for accessing that particular data. Next is integrity, is the prevention of unauthorized modification of information in which the information is not allowed to change, not allowed to modification, not allowed to interpret that information without the authorized privileges or authorized rights. Next is availability, is the prevention of unauthorized withholding of information or resources. So this is all about the computer security. Without these terms we cannot assume what is security and we cannot explain the security, how it works and how it is required for us. Now the next topic is security threats. There are many reasons why system need to be secure. First, malicious users may try to hack into the system to destroy it. When we are sending some data and when we are connecting with the network, then there is a number of persons are available on the network which are always present and which are always trying to access our data in unauthorized way, and they are always trying to compromise and they are always try to compromise with our data and want to access our data. We can say these kind of persons are the hackers, and we can say this is the cryptanalyst who is always monitoring our network and always trying to access our data which is traveling throughout the network. Then next one is power failure might bring the system down, and it may cause of some problems in the system and in the file system. If that kind of problem will occur suddenly or surprisingly, it will cause of loss of our data. Next is, a badly designed system may allow a user to accidentally destroy important data. This is also a kind of problem by which we can face, and we have to face some kind of loss. The next is, a system may not be able to function any longer because one user fills up the entire disk with garbage data. This kind of problem is also the major problem in day-to-day life. When we are accessing our files and when we are accessing our disk, so already it shows the disk is full because there is a kind of viruses and kind of threats are available which is already stored in that disk, which are not allowed to store more data inside this. So we have to manage and we have to work, we have to fight that kind of problem for preventing our data as in respect of loss, and to work on that for preventing loss of information. Next is security threats. We can classify the security threats into two types as mentioned below: the direct threats and indirect. Indirect, this is any direct attack on your specific system, whether from outside hackers or from disgruntled insiders, which are not permissible, which are not authorized, which directly attack your system and which want to access your content which is stored into your system and destroy it. Second, this is general random attack, most commonly computer viruses, computer worms or computer Trojan horses. This kind of viruses are active viruses which are always destroy our data, generate multiple copies of our data and convert their format which is not understandable and which is not easily convertible into readable form. So these are the kind of attacks and these are kind of method of hackers by which he always trying to attack on our data, always trying to hack our data, always trying to provide some losses and affecting our data inside the system. The next is security threats. These security attacks make the study of security measures very essential for the following reasons: to prevent loss of data, for prevention corruption of data, for prevention compromising of data, to prevent theft of data, to prevent sabotage of data, because all of these kind of threats are provide some loss to us and we have to compromise with our data, because the data after any threat will occur will get lost and we are not able to recover that data. So security policies and mechanisms are required and which are generated for this kind of problems. Computer system and their protection mechanism must be penetration resistance, in which it is not allowed to apply the try cases for hacking the data. Security evaluation have been performed for quite some time by mainly two different methods. The first is to classify system into a predefined set of categories, each with different security requirements. In this we have the mentioned requirement, we have the available conditions. On that basis we have to define the security evaluation methods. The other method is referred to as penetration testing, which is a form of stress testing exposing the weakness in a system, in which it generates the number of loopholes inside the system and we can provide the protection at that particular positions, at that particular systems, at that particular point out locations for securing our data or system. Security policies and mechanism. A security policy establishes accountability for information protection by defining a set of rules and protocols, conditions and practices that regulate how an organization manage, protect and distribute sensitive information throughout the network, and how to interact with the person with sensitive and important data for providing security at that level by which a third person or a hacker is not able to access our data, is not able to hack our data. Next is authentication. It is a process of verifying a user's identity through the use of a shared secret such as a password, a physical token or an artifact such as a key or a smart card or a biometric measure such as a fingerprint. These three types of authentication are commonly referred in this category. Something you have in that physical token, something you know, that is the shared secret information, something you are as like a biometric measures by which you can always trying to access the data in unauthorized way. Authentication. The goal of authentication is to provide reasonable assurance that anyone who attempts to access a system or network is a legitimate user, which is only permissible to authorized person. The passwords, the most common and least stringent form of authentication technology, demands that users provide only a valid account name and a valid password to obtain access to a system or network. This is the another and important way for providing the security on particular account, on particular data, from accessing the data in unauthorized way and from preventing our data in loss of information, in loss of data, and prevention from the hacking of that particular data. In that way, it also represents some system store the password of all users in a protected file. In that case, the user have to some smartness for preventing their password and data save inside the system where they are accessing the sites and where they are accessing the content. They have to check out some details in the system and some software information which are available in that particular system or active or not. If they are active, then stop their working and stop their running process and then start to working on that system, and after leave that system, try to remove the histories, try to remove the temporary files. Authentication encryption is based on one-way function that are cheap to compute but whose inverse is very expensive to compute. This represents the working of a system, and working of the encryption process is very cheap, but if it is not work, then it becomes very expensive for us. This is the encryption process all about. In this, we have some limitation also. Users tend to choose some password that are not easy to guess. We have to use in that password some combinations which are not easy guess, that are like a special symbol, uppercase, lowercase, and combination of numbers, alphabetical, reversible order, sorted order, unsorted order. We have to generate that kind of a secure password which is not guessable with our personal details, which is not guessable with our vehicle numbers. That should be like a combination which knows only you about them. Alternative forms of authentication is biometrics, security devices or artifacts, concentric ring authentication. These all used for the authentications, as well as protection in computer system. Automation brings to security and automated system, if properly constructed, can bestow a number of benefits as well. An automated system can also offer new kinds of access control inside the permission set inside the system and allow the permission to execute. Certain programs can be granted or denied so that specific operation can be restricted to apply on the system, and to the designated users. In the same way, in the protection in computer system, we have the information contained in the system must be protected from three kinds of threat generally. First, the unauthorized disclosure. Second, the unauthorized modification of the data. And the next one, unauthorized withholding of information which is not allowed to hold and store and forward in the security mechanism. The next is security model. In this, security policy and security model is followed for representing the details and about the security mechanism. The security policy outline several high-level points: how the data is accessed, the amount of security required, and what the steps are when these requirements are not met. When this kind of issues comes in the system, we have to work on it, we have to provide the policy, and we have to apply the policy for providing the accessing and for providing the secure authorization for the users, for accessing the files, for accessing the content. And the same way, we have the security model is more in depth and support the security policy for applying on the content on which a authorized user only can access and in an authorized way. Security models are an important concept in the design of any security system because it is a kind of prototype. It helps to user how it works in explaining the content, and it also helps to explain the authorized user how it operates and how it works when you apply the password and security on the particular file system. Next is security model. In access matrix model, the access matrix model for computer protection is based on abstraction of operating system structure which represent the number of access permission set and which represent the number of files which are accessible by a particular node. There are three principal components in the access matrix model: a set of passive objects, a set of active subjects which may manipulate the object. Passive objects just reflect the changes, just reflect the uses, but cannot allow to manipulate the content or object. A set of rules governing the manipulation of objects by subjects on an authorized way. Only authorized person who is having the authorized password and ID with the access rights can allow to manipulate the changes, only can allow to update the system. Next is continue with the security model. We have the file system in which we have the number of users and number of files, in which we mentioned the authorization and the number of rights which the number of users having. And suppose there is the number of user 1, 2, 3. User 1 have the rights in file 1 for read and write, and in file 2 just for read the operation, and in file 3 it has the all combination read, write, execute, and it can works like an administrator and it can works like an owner of the file. Any content it can write and execute and read from the file. Same manner user 2 have the rights for the file 3, and the same manner user 3 have the rights for accessing the content into the file 3 system. So in the file 2 there is the R represent the read operation and represent the only restrictive access into that particular file. In that way a user is not allowed to make changes inside the file, it can only read the file. The next is with the continuation of the same topic, security model, which represents the control in a mandatory access control or discretionary access control. In mandatory access control, which represent the number of users have the access rights to access particular files, to access particular content, for allowing the system, for accessing the system, but they are not have the full rights for allow the changes into the system. Mandatory access control is a kind of control which have the login entry and log off entry, but not have the complete information but not have the complete right to apply the changes onto the file. Next is discretionary access control, in which resource owners and administrator jointly control access to resources or apply some mechanism for accessing the content or resources into the system. Next is rule-based access control, in which we define some rules how to access into the system and which one is permissible to access to that particular system and how it can changes and apply the changes into the files. Next is role-based access control, in which we define who is the user, who is the guest user, who is the admin of that particular file, and who have the rights for apply the changes and providing the accessing into that system for other user and itself also. Next is take grant model. In this it takes grants to access and allow to access into the files to the number of user on their access privileges by looking after their access rights and their designations and their rule and role based protocols as well as access control protocol. Here protocol mention the rules and regulation which are mentioned by the organization for accessing the particular file system. Next is security model. In this model there is a two types, rule based access control and role based access control are majorly work which represent rule based, the set of rules and specific sequence and operations which they can perform on particular file, and role based access control which represent who is developer, who is system analyst and who is the administrator, and already mentioned their rights and access, how they will access and how much they have the rights for apply the changes and for doing the operations in that particular file. Next one is take grant model, which represent how and whom to allow accessing the file and who have the rights to access that file and which one can get the access in that particular file, taking grant from this and for accessing the content and then release their access rights to that system. Next is security model, multi-level models. In this we have corresponds to the multi-level policies and multi-level sensitivity of users which can have the access rights according to their clearance. Because of the way they control security, they have also been called data flow models. They control the allowed flow of data between number of levels, between number of users from beginning to end, how many users are access the files and how many persons, how many role based control are there for providing the comfortably accessing inside the file system and apply the security on that particular file for accessing the content. Now Bell-LaPadula model intended to control leakage of information between levels. When the data is transferring from one level to another level, we have to apply a kind of mechanism or security models for preventing leakage of content or information at every level. Biba model, which controls the integrity, which we discussed in the first slide of this unit. Lattice model, which generalize the partially ordered levels of the previous model using the concept of mathematical lattices, in which it mentioned the permission set to particular users or particular accessing control persons or role based access control persons. Bell and LaPadula model. Bell and LaPadula use finite state machines to formalize their model, in which they have to define which input accept by which state and which input accept by which machine and at what level it will reach, at what state it will reach and which kind of output it will generate. That all undercome inside this model, which represent the security inside the system. And this is the another access matrix which define the above terms in a matrix form in respect of user access, which have the access of read only, append of file, execute, read and write, every kind of permission set it has. Now security model for a system state to be secure, it should hold the following two properties. First, simple security property, which is generalized form of security model. Another is property, star property, which represent the fixed or restrictive authorization for accessing the content. The security level are used to determine whether appropriate access rights are there or not. There are also a few problems associated with this model. First, for a subject of a higher level, all of its information is considered as the same level. Security model for an environment where security levels are not hierarchically related, the model does not account for the transfer of information between these domains. The model does not allow changes in access permission set. The model deals only with confidentiality but not on integrity, because the confidentiality, permission set and authorizations are the main pillar of security. We have to work on it. We have to follow this for prevention of our files from unauthorized access or from loss of information, to carry on this kind of mechanism for security. Next is security models. BIBA integrity model. Inside this model is a modification of the Bell-LaPadula model with the emphasis on the integrity, but into this two properties are mainly followed. SI property, a subject may have right access to an object only if the security level of the subject is either higher or equal to the level of the object which we are accessing and which we are using for accessing the files and content of that particular object. Next is integrity property. A subject has the read-only access to an object O, then it can also have the write access to another object P only if the security level of P is either lower or equal to the level of O. It can do one at a time. The major problem associated with this model is that there is not a practical model that can fulfill the confidentiality of the Bell-LaPadula model and the integrity of the BIBA model. So all these models provide the mechanism for security, for prevention of our file from unauthorized access and from loss of information from unauthorized users, hacking content. So we have to follow the security for using the files and for providing the access into the files, and there is a number of issues which can arise in respect of every model, and some problems are solved by the other model inside the security mechanism.